All right, so now we're going to take a look at applying the table on an even more complex circuit. I went ahead and drew it out in advance so that we could save a little bit of time on that. I've got a battery here, 9 volts is what it is. We've got resistor A, which is 10 ohms, resistor B, which we don't actually know the resistance of. I'm giving you an unknown resistor. Resistance C, which is 20 ohms, resistor D, which is 10 ohms, and resistor E, which is also 10 ohms. I think I've actually given you more information than I would need to on a regular basis, but while I didn't give you much information about resistor B, at least on its resistance, I can tell you this, that the potential difference across it is 3 volts, and I judge the brightness of this. We're going to pretend that each of these are light bulbs. We're going to start looking at that, because light bulbs are a great way for us to imagine these. Light bulbs. I judge the brightness of this light bulb to be 0.6 watts. You can take a look at one of the previous videos where we looked at brightnesses of bulbs to put that in perspective. Okay, so I've written out my table. I have total for the entire circuit, A, B, C, D, and E. So I've got a lot of things that I got to keep track of. What I'd recommend is let's start by filling in information we know. We know that the total for the circuit is 9 volts. Oh, silly me. Let's write out Ohm's law at the top. V equals, or I'm sorry, delta V equals IR. Great. While I've got the black marker in hand, let's fill in some of the things that we do know resistance-wise. 10 ohms. D was also 10 ohms. C was 20 ohms. B was, question mark. A was 10 ohms. And we do not know the total resistance of the circuit. Okay, I'm going to fill in some other information. B, we said that the potential difference across it was 3 volts. Now, I filled in parts of my table, and I don't know what to do, actually. I don't have any rows that I can fill anything in. I've only got one piece of information in each row. I can't use junction rule because I know nothing about the currents. Maybe I can apply loop rule. So let's go ahead and do loop rule. Let's get started on this. So I go across the battery, and the battery gives me plus 9 volts. Great. Oops, plus 9 volts. Then I continue going. I go across A, so I'm going to minus delta VA. Great. And then I keep going, and then I go across B. Now, I don't know delta VA, but maybe that's what I'm going to solve for. I do know delta VB, which is 3 volts. Great. And I keep going, and then I come across E, delta VE. Then I get back to where I started, so all of that equals 0, but the problem is there are 2 things I don't know. And going the other way isn't going to help, because I don't know anything about the other way. Now, this is a common thing, and I like to do this to you all. You're probably not going to see it outside of my class, but don't ignore information you're given. I wrote this down, and sometimes it can be hard to see, because I'm going to give you information like this in a paragraph. I also gave you some info about the power. Okay, the power of this one is 0.6 watts. Now, I haven't told you what I'm looking for. In short, I'm going to tell you, let's fill in the entire chart, or table, and the biggest thing that I want to know is rank each of these light bulbs from which one is brightest to which one is dimmest. And we're going to do that by getting the powers. Okay, great. Now, the other reason that I bring up the power is this, because many people get stuck on the P equals I delta V, but I also told you that it is equal to I squared R, and it is also equal to delta V squared over R. Now, it's useful keeping track of all of those, because then, depending on what information you have, you can fill in any of these others. Now that I've got that, I know that P equals I delta V, so 0.6 watts equals my current through B, IB, times 3 volts, the potential difference across it. So I do 0.6 divided by 3 volts, and I have now found out that the current going through B is 0.2 amp. Now I can take 3 volts times that, and I end up with, not 3 volts times that. I take 3 volts divided by 0.2, and I find that the resistance of B is 15 ohms. Now I could have also done that by taking V squared. That'd be 3 squared, that's 9, divided by divided by my power. So I would have, let me write this out so you can see what I'm doing. Delta V squared over R equals R power. So if I rearrange this, I can end up with R is equal to delta V squared over R power. I work that out, and I end up with 9 divided by 0.6, and I end up with 15 ohms. You get the same answer either way. Great. I love having options. Okay, great. So now I've got this filled in. All right. Now what can I do? So I filled in one of my rows. Let's see. I didn't learn anything new about my potential differences, so I know that loop rule is a dead end. And my junction rule, well, I know how much is going through this side, but I don't know how much is going through that side, so I can't really do much with it. So I can't use my trick for the potential differences. I can't use my trick for the currents. So, hey, I filled in one of the unknown resistances. I can now find the equivalent resistance. Well, I'm going to start with the smallest part of my circuit. These two will combine to be 30, and I'll end up with 15 in parallel with 30. I'm going to get a bit quicker in how I draw this. This one should be green because it's the equivalent resistance of those two. But I would have 1 over 15 ohm plus 1 over 30 ohm equals 1 over my equivalent resistance. That'd be the same as 2 over 30 plus 1 over 30, which is 3 over 30 ohms, which means my equivalent resistance for those two is equal to 10 ohms. If I were to redraw this out, I like to do that every so often, especially when I start to have trouble remembering all of it. We know that this is 10 ohms, this is 10 ohms, and now we have an equivalent resistance for this entire section that is equal to 10 ohms. I will also point out that the equivalent resistance of 10 ohms is less than the lower of the two. This was 30 and this was 15. Remember, the equivalent resistance of parallel must be less than any of the ones into it. And that means, since these are all now in series, my total equivalent resistance is 30 ohms. Great. We're making tracks. 9 volts divided by 30 ohms. We now find that the total current in my circuit is 0.3 amp. And since 0.3 amp is coming out of my battery, it has no choice but to go through A, which means 0.3, the total current, is going through A, which allows me to then take 0.3 times 10. We now know that the potential drop across resistor A is 3 volts. I'm moving pretty quickly here, but once you get some practice, you'll start doing this too. Great. Now I know. Let's keep going with what we know. We know we've been getting some good results with our current, so we know that 0.3 amps goes down this way, hits this junction, and because we have this information from B, we know that 0.2 amps goes this way, which means by junction rule, 0.1 amp must go this way over to C. It goes through C, and then it goes through D. It is not used up because they continue flowing through. We also know that if we have 0.2 amps coming in here and 0.1 amps coming in here, we have 0.3 amp coming down here, and all of that goes through resistor E, which is 0.3 amps, and then eventually goes back into the battery in accordance with junction rule, just as we knew. And now you could go through and you could apply Ohm's law for each of these. So 0.1 times 20, that means that we have 2 volts across C. 0.1 times 10, that's 1 volt here, and then 0.3 times 10, that's 3 volts here. Let's double check. We never actually applied loop rule on this, even though I tried and then got stuck because I started filling things in another way. But let's double check. So if I go across here, this gives me 9. I go across A, I lose 3, so that puts me at 6. I go across B, I lose another 3, that puts me at 3. And I go across E, there goes the final 3. Both of these, we found out later, were 3 volts. We could have come back and filled them in, but 9 minus 3 minus 3 minus 3 equals 0. Loop rule does hold. If I go the other way, I gain 9, lose 3, lose 2, lose 1, and then lose another 3. That brings us back to 0. Loop rule applies. All right, now we're in the home stretch. I asked you which one of these is the brightest. We filled in all the information that we could want to know about our circuit. So let's find our powers and be done. The total power of the circuit is 0.3 times 9 volts. That gives me 2.7 watts. All right. The power of resistor A is 0.3 times 3. That's 0.9 watts. We already know B, that was 0.6. We said that, let's see, 2 times 0.1 is 0.2 watts. 1 times 0.1 is 0.1 watts. And then 3, this is also 0.9 watts. Okay, so my big question, which bulb is the brightest? Well, it turns out A and E are actually the same brightness. They're both 0.9 watts. The second brightest is B, 0.6 watts, and Let's see, the third brightest is C, and then the dimmest is actually going to be D at 0.1 watts. This is great because we can actually look through that. On top of that, the battery is putting out 2.7 joules per second. That's what a watt is. And all of these together, each one is consuming this much per second. 0.9 plus, this is 1.0, plus 0.2, that's 1.2, 2.1, 2.7. We see once again, energy is conserved. The battery is putting out 2.7 joules every second, and this entire circuit is using 2.7 joules every second. 0.9 joules here, 0.9 joules here, 0.6, 0.2, 0.1. Great. A lot of great information. We're going to keep building on this, but this is a great example of how the table can allow you to go through a really complex circuit quickly and easily. All right.